Okay, in section 8.5, we are going to be reducing radicals to the same order. I'm just going to do a couple problems from here just to show you how it's done. Number 3 is the square root of 2, and we're not really adding them or anything, we're just getting them to be the same order. Square root of 2 and the 5th root of 4. Okay, so the square root of 2, that can be written, we want to, in order to get them to be the same order, right now one of them's got an index of 5 and one's got an index of 2. We want them to be the same order, so we're going to convert them to fractional exponents. So the square root of 2 can be written as 2 to the 1/2. And the square root of 4, or I'm sorry, the 5th root of 4 can be written as 4 to the 1/5. So now we can really see those fractions and their fractional exponents and try to think, what do we need in order to get them to have the same denominator? Because if their denominators are the same, written in this form, then when you put them back under a radical, their denominators will become their index. If their indexes are the same, we've done our job. We've reduced them to the same order. So let's 1/2 and 1/5. I'm thinking the least common multiple for them would be 10. So how can we get 1/2 to have a denominator of 10? Multiply it by 5 over 5. That way you don't change anything with the fraction, you just make it bigger both on the top and the bottom. Get it to do what you need it to do. That looks like a mixed number. Let's make it look like an exponent. There we go. 2 to the 5/10. 4, the 1/5 we're going to multiply by 2 over 2. That'll get us to have 2/10. Now they have the same denominators. Now you just put them back under their radical, like so. 2 to the 5th, and the 10 on the outside. Bottom goes on the outside. And the 4 squared, and the 10 on the outside. 4 to the 2/10. So last step would be you take the numbers in here and go ahead and work out the power. So that will be 2 to the 5th is 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So we got 10th root of 32, and the 10th root of 4 squared is 16. And that is your answer. That is how we reduce them to the same order. Problem 7 is the cubed root of 4 and square root of 10. So cubed root of 4 can be taken out of the radical and written like this, 4 to the 1/3. And 10 can be written 10 to the 1/2 because it's just a square root. All right, now let's try to give them like denominators so that the denominators are their orders, their indexes. So 3 and 2, okay. 2 over 2 for this one will give us a denominator of 6. What will give us a denominator of 6 for this one? 3 over 3. Okay. 4 squared, or 4 to the 2/6, and 10 to the 3/6. Now they have the same order, and I'm just going to put them back under their radical, and our work is done. After I 4 to the 2/6 and 10 to the 3 under a 6th root, after you go ahead and expand that out. So the 6th root of 16 and the 6th root of 10 cubed, that's 1,000. Okay? All right. So if we were adding these, they would be ready to add now that they have the same order. Okay, let's do number 8 now. We have the 4th root of 3 and the 6th root of 11. We want these to be the same order. In order to do that, we gotta bring them out from under their radical, give them a fractional exponent. 3 to the 1/4 is how we would write that. And this one, we will write it as 11 to the 1/6. Now we can compare denominator of 4, denominator of 6. What kind of denominator can we give them so that they will match up? I'm thinking 8, 12. All right, 12 will be the least common multiple. of these two. So to get to 12, 4 needs to be multiplied by 3 over 3, this fraction. To get to 12, the 1/6 will need 2 over 2. All right, let's just do our math. 3 to the 3/12 and 11 to the 2/12. Okay, so we've got their denominators matching. Now we just put them back under their radical. 3, this stays with the 3, cubed, 12th root. And the 12th root of 11 squared. Now they've been rewritten. Now we just need to work out the power. 12th root of 3 cubed is 27. And the 12th root of 11 squared. 11 times 11 is, I think, 121. Let me check that. 11 times 11 is 121, yes. So this would be our finished product just for this, since these were the numbers they gave us and they didn't tell us to add them or anything. They just said get them to the same order.